All right, we might get, or we might make a start. So thanks again for everyone who has joined us again for this is the last for the first series of webinars. We've been running these for the last 6 weeks, and thanks for all those who have joined along the way, and those of you who are watching on demand in other parts of the world where you're well asleep right now. So today we're going to deep dive into the process mining techniques, and we're going to be looking at that using a tool called Apromore. So this is a follow-on from a previous webinar we did about 3 or 4 weeks ago. I think it was 4 weeks ago. And so you may not have seen that. So you can go and catch that up if you're still interested. If this is something that's new to you and you want to see that introduction into process mining, please go and catch that. I'll have some links coming up in a second that has that information on it, where you can go and catch that on demand. So today's webinar will be presented by Professor Marcello LaRussa, who's the CEO of Apromore, and Ian Edwards, who is a senior consultant for Leonardo. Thanks, guys, for joining us again.
Pleasure.
Thank you.
So before we kick on, just a bit more about Apromore. So Apromore is a leading provider of open source solutions for process mining and AI-driven business process improvement. So their vision, and I'm sure that Marcello will talk more about this, is to democratize process mining to enable organizations to achieve that digital transparency. And they've helped dozens of organizations leverage the full potential of transactional data, business transactional data, to enhance productivity. And this process is the result of over 10 years of research, innovation from the University of Melbourne and the University of Tartu in Estonia, and other universities and organizations worldwide. So just before we kick off, this has been the sort of schedule of webinars that we've done over the last few weeks. Again, you can catch any of these on demand at that URL, info.leonardo.com.au/weekly Wednesday webinar. You can just click through and sign up and watch those on demand. But other than that, I'm going to hand it over to Marcello and Ian to talk to us about process mining in action. I'll just give you control, Marcello.
Thank you very much, Ian. Right, let me see if, so tell me if you're seeing my screen.
That's all right, you can just have control of my screen. So let me just. Go for it.
All right, so we had last month an introductory webinar on process mining, where we described what process mining is all about and what are the techniques within process mining and how they can be used. So basically today we will show some of these techniques in action in the context of a concrete process mining tool like Apromore. But let's start with a very short recap of process mining. As we said last time, and for those who didn't have a chance to attend the previous webinar, process mining is about understanding, getting an intimate understanding of our business processes, starting from transactional data that is automatically logged by the information systems available within our organization. So as such, process mining is preaching a new way for managing operations within an organization with the objective of improving organizational performance. And basically what it's preaching is the shift from confidence-based business process management, where the confidence in our understanding of our own operations comes from the stakeholders of the organization that are involved in the management and in the execution of the processes, such as a claims handler or a claims manager in the context of an insurance organization, towards an evidence-based approach to BPM, where the evidence is coming directly from the data, and as such, it is unbiased. So, very quickly, the idea of process mining is to tap into historical data that have already been recorded by enterprise systems or IoT devices, enterprise systems like an ERP system such as SAP, or a CRM system like Salesforce, or a domain-specific system, such as a claim management system in an insurance company, so tapping into this historical data or live data as it comes in from a live stream of events that relate to open cases, like all the claims that we are currently handling, and use this data as input to a series of process mining algorithms to extract what we call actionable process knowledge. So it's intimate knowledge of the processes that are represented by this data. But it is also actionable because whenever we find issues, it equips us with remedial actions that we can take to rectify such issues. For example, to overcome a bottleneck or to address a non-compliance issue. And this knowledge can take multiple forms. First and foremost, as we will see soon in the demo, the idea is to automatically extract, automatically reverse engineer a process model out of this data. Once we've got this process model, then we can enhance this with a range of statistics related to the frequency or the duration of the various activities and transitions from one activity onto the next. For example, we can extract automatically average durations for tasks and waiting times between tasks. We can also check the compliance of the process as it is enacted in the organization, meaning as it is represented by the data that we extract from the systems, with a normative model or a set of business rules that might be available in our organization. For example, we might be able to check if and how often we violate a 4 eyes principle. Then we can also compare different variants of the same process. Consider again the example of a claim handling process, and now look at it from different perspectives. For example, look at it from different regions or states, e.g. Queensland versus Victoria versus New South Wales, different types of customers, of different performance ranges. For example, those that complete within 3 days and those that take longer than the service level agreement with the customer. The idea of what we call variant analysis is to compare different variants in order to identify root causes for differences. And finally, when we tap into live data, then the outcome is predictions about the cases that are currently being unfolded. For example, how long it's going to take for this claim to complete? Will the loan application, will the loan offer be accepted or rejected by the loan applicant? So we can predict the remaining time, the outcome, the next activity or likely continuation of a case. And that can assist operation managers to avoid the issues from arising by anticipating them thanks to this predictive analytics. Right, so we concluded a last seminar by overviewing the key value enablers for process mining. So essentially, okay, we understand that process mining provides a range of techniques, but what can we actually do more specifically with these techniques? Well, first and foremost, the idea of using process mining is indeed to achieve transparency. So to get a good understanding of how our operations are actually being conducted, not as we imagine them. So we can do that by means of automated process discovery, right? So we automatically extract the process model. And that transparency, it's a starting point to enable other values such as efficiency. For example, we can enhance the process model with performance statistics. We can profile different performance dimensions such as duration or distribution of cases over time through performance dashboards. Or we can animate, we can replay the transactional data on top of the process model that we have automatically extracted from our data set in order to inspect temporal aspects of our process, so basically how cases have evolved over time. There are use cases also that include quality, like the quality of the service or the product that we offer to our customer, and hence the customer experience. We can use techniques from variance analysis for that. For example, contrast cases that are performed within the agreed service level with the customer, like say within 3 days, versus those that take longer, and identify why customer experience deteriorates in those cases that take longer than 3 days. We can also use it for compliance and more in general for governance, risk and compliance. For example, we may identify discrepancies between a normative model, say in the BPMN language, that has been created within the organization, or it has been provided by our software vendor, e.g. SAP provides a collection of normative models to describe the processes that are supported by SAP out of the box, like sales, accounting, payroll, and so on. So we want to compare how close do we get to this best practice. Or we can check some internal policies or the compliance with normative regulations, for example, the 4I principle that I was mentioning before. And finally, another interesting use case, and of course this diagram is not, there is no intention for this to be comprehensive. There are also other use cases that, given the time restriction, we won't be able to cover. But another one, the last one that we might be able to cover today is the agility, meaning the ability to identify how ready is our process to change to an always changing environment. And we can see that too with COVID these days, the need to switch to different operating models, and so how all our operations get adapted in order to cope with this changing environment. Here we can use techniques that marry the experience from process mining with that from simulation. Like we automatically discover the as-is model, and then we use it as a starting point to evaluate different what-if scenarios. What if this situation occurs? What if this change happens? We can also do change analysis, meaning looking at the historical evolution of a given process over time. For example, compare the way we were operating before COVID versus the way we are currently operating during COVID, and one day comparing that with the post-COVID operating model. And finally, predictive and prescriptive monitoring. So check in real time predictions about the continuation, the likely continuation of the open cases in order to anticipate problems. Right, so that was like a 3 minutes recap of last time's webinar, our 101 introduction on process mining. Let's get concrete now. So what we would like to do is to go through some of these use cases, starting indeed from the transparency one, using Apromore. Apromore is an open source process mining platform that we've been developing for over 10 years. It started as a research project and eventually ended up in a spin-off company of the University of Melbourne. So currently it's a product that we are commercializing, also in partnership with Leonardo. Right, so let me switch to the live demo. And what I'd like to do is indeed to start from a concrete okay, so let me start from a concrete example. What you see here on the screen is a log that we extracted from SAP and refers to an order-to-cash process. And in taking a look at this log, it is a comma-separated value where basically each row represents a so-called event, and each row represents each column represents an event attribute. We can see that there are some key attributes that are required in order to carry out a process mining exercise. First of all, we need to have a case identifier. This is basically a unique identifier of each case. In the case of an order-to-cash process, that would be the order ID. In the case of a claim handling process, would be the claim number, or the loan application, or the student admission number, right? So the case ID clearly varies from domain to domain. Then we need to have a reference to the activity of the process that has been performed within that case. You can see here some examples like orders, goods issues, delivery, and you see that the data may actually be dirty. In this particular example, we have a few rows where they have a null value, so the label of the activity is not present. Now, if we scroll down through the many attributes that are available in this large data set, we can see that SAP has another attribute called SAP transaction code text, which actually provides a better name for activity. So we can actually use that as a reference to the activity. So we need the case identifier, we need the reference to the activity, and at the bare minimum, we need the timestamp of completion. So we need to know when that particular activity, in that case, has completed. Sometimes we may also find the start timestamp. If that is the case, then the tool will be able to draw more detailed statistics. For example, it will be able to distinguish the processing time, which is the actual time taken to perform the tasks, from the waiting time, which is the time that we wait between the completion of a task and the beginning of the subsequent task. And you see that now this log has a variety of other attributes. And these attributes, such as the username, like the unique ID of the person that performed that activity in that case, or the subtable, the fiscal year, document number, or the order quantity and value, all this extra information can be used to extract richer analytics. For example, in the context of variant analysis, we could use this to distinguish variants based on the order volume, right? On the overall value of the goods being ordered. Right, but let's switch into the tool. So Apromore is a software as a service, so you can access it through a web interface. Once you log in, what you'll see is basically a portal. And this portal, at its core, provides repository functionalities where files are organized in folders and subfolders. And Apromore, besides offering a range of process mining capabilities, it also offers process modeling capabilities. So the files identified with this flowchart icon, they actually represent process models in BPMN. So if I double click on one of those, you'll see that the editor of Apromore will fire up. And this is just a fully fledged BPMN 2.0 editor that we can use to create, edit, save, version control, and share in a collaborative environment different process models. So this could be an order to cash example that we actually created by hand. You see that it's quite refined. But of course, today's interest is in the process mining bit. So let me upload that example log that I showed before.
As that's being uploaded, sorry, hang on. As that's being uploaded, I think the critical thing around those data files is that even if your data does not have one single attribute that is a unique case ID, there are ways to concatenate multiple fields together or simply script multiple pieces of data together to create that unique case ID. So it is critical that you extract as much data as you potentially can before you decide which data to exclude, just so that you've got some options as to how to create this data set.
Yes, and especially if your end-to-end process is supported by multiple systems. For example, you might have a system for logging in transactions specifically related to orders, and another system or even application within the same system that records events related to the invoicing part of that order to cash process. Then you might have different case IDs, one for the order and the other for the invoice. So you need to find the key to join tables coming from different systems or applications, modules within the same system in order to be able to cover the full end-to-end process, because this is where process mining had the most value, when you are able to reconstruct the full process model, so the full business process from the very beginning to the very end. Like in this case, the tool automatically identifies that this column refers to the case ID, this one refers to the activity, but we can actually ignore this one because it has some invalid values, and actually pick the SAP transaction code that we discussed before, SAP transaction code text. I can make that an activity. And then you see that there is also a timestamp of completion in this log, and the tool has automatically picked up the format. And you know, there is American English, there is British English, there are different formats in which timestamp can be represented, you know, 2 digits or 4 digits for the year, minutes versus minutes, seconds and milliseconds, and so on. So if you want to, you can actually modify the time format, but typically the tool will automatically guess that. There is also an option to change the encoding. For example, if you have logs coming from Central Europe versus Eastern Europe, Asia, and so on. Right, so once that operation has been done, then you can import the log. And once the log has been imported into the system, basically all you need to do is to double click on that log to automatically reverse engineer the process model. And what you see here indeed is what we call the process map, meaning a flowchart representation of the tasks in this process and the transitions between a task and the task that has been observed immediately after the other task within this log. But before getting into the details of this map, let's take a quick look at the statistics of this log. You see that in this log we are looking at about 35,000 cases and 1.3 thousand variants. So this is a very important concept in process mining. The variants are the paths. So the sequences that cases, in this case orders, can follow. And you see that there is a quite large number of variants. So over 1,000 different ways in which an order can be performed, even if there are only 26 activities in this log. So this number is already indicative of the complexity of this process. And as you will see, often the way we picture in our mind, and so we model on paper, these processes is much simpler than what these processes actually are in reality. And this is already a first indication of the degree of complexity of this process. Here we can see some temporal statistics, and also here there is something, let's say, bizarre or at least interesting. You see that we are traveling on an average duration of 5.35 months. You know, depending on the product being ordered, that might not be acceptable. But what is most staggering is actually the maximum duration and the minimum duration. There is, you know, the minimum duration is a bit more than 1 minute, but the maximum is nearly 3 years. Now, the minimum is most likely because there are incomplete cases. When you take a snapshot of a data set, there are most likely tails of cases that actually started before your snapshot. This starts from mid-July 15 until July 18, right? So it's about 3 years worth of data. But there are clearly cases that started before, as well as you will see the heads of cases that are incomplete because they concluded after this date. So probably the minimum being so low is because of that. But the maximum of nearly 3 years is indicative of a degradation of performance in this example. Okay. So let's take a closer look at this model. As we said before, each box represents an activity, and each arc represents the transition from an activity to another activity that has been observed immediately next within the same case. We can also see that these activities and arcs have been annotated with some numbers. These represent the frequency, specifically the total number of cases through which an activity has been performed, or through which a particular transition between activities has been performed. So you see that here we have a range of statistics related to the frequency of this process that we can use to overlay on this model. And the darker the color for an activity, the more frequently we have observed that particular task in our dataset. Likewise, the thicker the arc, the more frequently we have observed that particular handover of work between two activities. So, in terms of transparency, the first thing that we can observe is that this process appears to be rather complex. We can see this from this high number of case variants, and we can also see it from the large number of activities, but also the way they are arranged in the canvas. It's sort of hard to see a clear flow of control from left to right, from the beginning to the end. In fact, we can see that there are some loops, some reworks and repetitions, activities that are done very frequently, like this one, and other activities that are barely done, like, for example, change contract is done in 12 out of 35,000 cases.
Marcello, there's actually a question which is quite topical that's just come up in terms of why are the numbers on the activities and the arcs not matching? And that might be a nice lead into the arcs.
Yeah, so that is because what we are looking at is a specific abstraction level for this log. In fact, we are not really looking at the full data set here. If we look at these abstraction settings, we are looking at all 100% of nodes, so all 26 activities, but we are only looking at the 10% most frequent arcs. And this is a way that the tool is a mechanism that the tool offers to tackle that complexity inherent in this data set, so the complexity of the underlying process. So what I can do is actually play with these abstraction sliders to show or hide more or less details, both in terms of nodes as well as in terms of objects. So given that at the moment I'm only showing the top 10% most frequent arcs, the numbers do not add up. So you see, for example, that I've got about 24,000 cases coming into this activity create delivery document. The activity itself is done 26.7 thousand times, but there is nearly 19,000 cases, only 19,000 cases that are coming out. So about 7,000 are missing. And the fact is that really some arcs are being hidden here. So what I'll do now is that I will start to increase the percentage of arcs. So let me reload this because in the meantime, it went to a timeout because of inactivity. So what I'll do is that I'll start increasing the percentage of arcs. And as I increase the percentage of arcs, you will see that more and more arcs that are less frequent will pop up. Right? So you see now, create delivery document. There we had the 18,971 going into this activity, create SD sales invoice. But then there are 1,580 coming back. Another 7,567 now going to another activity here, the change of the outbound delivery. And there are also some cases that are actually looping back into the same activity, like that create delivery document needs to be repeated, so there is some rework because something went wrong. So it was like the correction of some error. However, what we can also see, besides these new arcs popping up, is indeed that the complexity of the process increases, right? So let's keep moving this, say let's bring this to 60% now. You see that this is now looking more and more like a blob. And this is because, as we said before, we have 1,300 different paths that an order can follow. So if I put it to 100%, you'll see that indeed the complexity of this process explodes, showing the naked complexity of this process, so showing really the reality. Now, if you look at a blob like this, you would never dream of modeling this yourself on paper. And this is indeed the starting point of process mining, showing you how reality often differs from the way we imagine it. We might have likely modeled this as a very, very simple process. For example, something like this, right? Where we have only a few nodes and only the top 10% arcs, right? But in reality, the process is much more complex than that, right? So that is yes.
Sorry, do you want to just talk quickly about parallelism? Because there's another question that might be worthwhile doing.
Sure. So now, as I move through these sliders and show more or less details, another thing that I can do at any point in time in Apromore is to actually dynamically switch from the process map, which is what you see now, which is a low-level graph-based representation of the log, so of your data set, into a BPMN model. And I can use this switch up here to do that. When I switch it to BPMN, then the tool will automatically identify these gateways. And these gateways allow me to specify, or actually the tool does that for us, it automatically specifies the precise order relationships between activities. For example, we can see here that there is an exclusive relationship between create building document and post document. So this model appears much simpler to handle. Now, as I increase the number of arcs, then more and more gateways, which has these diamond shapes in BPMN, will pop up, and these gateways are used to capture the model, the order relationships between activities. So let me see if we have some parallelism in this example. So Apromore is able to discover gateways of type XOR, like these ones, of type AND, like this one, where there are parallel branches, and of type OR. For example, this is an OR join, also called synchronizing merge, to basically reconnect paths that are coming from different potentially parallel activities. So basically, in order to be coming back to the question, in order to be able to pinpoint the specific order relationships between activities, we need to switch from the process map to the BPMN model. And in BPMN, then we will have XOR and OR gateways. And look, this is the as-is process, right? This is what we can use as a starting point for simulation, for example, or to document reality, because this is a model in BPMN, so it's a language that is understandable by our process analysts.
So do you want to just show what happens when you increase or decrease that parallelism slider?
Yes, so there is also a parallelism slider that allows us to be more or less sensitive to parallelism. Now, parallelism, there is a heuristic behind Apromore to discover these parallel flows. So basically what I'm doing by increasing this parallelism threshold is to increase the tolerance to potentially parallel paths. And I say potentially because basically what the algorithm tries to do is to check that there is a balance in the frequency between the potentially parallel paths. Now, if I increase this threshold, then it means that even if there is quite a large difference in the frequency, say that invoice raised has a frequency of 10, whereas goods shipped has a frequency of 100, then it will still recognize them as in parallel. If they are observed in different orders. Whereas if I reduce this to 0, then basically the tool will adopt a strict parallelism semantic, meaning that the frequency might be of the two potentially parallel paths must be almost the same, like 100 versus 90, like plus or minus 10%. So this is a way to fine-tune the discovery of parallelism, because parallelism is basically based on a heuristic. Okay, so in terms of transparency, what we can see, for example, if I switch back to the process map, is that indeed there are a number of rework loops. And this is an indication of a potential efficiency problem. So moving into, going back to our value adding process mining slide, then basically what I'm looking at now is the efficiency dimension. How can I use process mining to pinpoint potential inefficiency or loss of efficiency in our operations? So here, for example, we can use the waste analysis approach from Lean by utilizing the different enhancements that the tool provides to identify possible sources of waste. A self-loop or a loop-back path is indicative of some rework. So why do we need to perform this activity a large number of times and repeat it within the case. So we could also look at a different type of frequency, for example, the maximum frequency, to see how many times maximum a given activity or arc has been observed within the same case. And that is clearly indicative of rework and repetition. Take a look, for example, at this activity, change scheduling agreement. There is at least one case in this log where such an activity has been performed 35 times. So essentially for the same order, the scheduling agreement has been changed 35 times. This is probably not the way we wish to operate, right? So that is a potential source of waste, because that will definitely cause delays in the overall duration of the process. Another one is the creation of the delivery document that is done 15 times. So this rework loop view, or these short loops here, allow, like these back and forth ping pong effects, allow us to identify potential rework.
There's a good, sorry, Michelle,
Sure.
just really quickly, there's a really good question there which we should probably answer now, around how do we choose the level of the nodes and arcs to show. The way I would answer that is depending on the intent of what your analysis is. So obviously, if you move the nodes to the left, you start to get a much simpler view of the process. And this might be, used in terms of trying to understand for, let's say, some decision makers or execs, what are the functions being performed, or you might be trying to understand what business rules we need to invoke. Or like I was talking to another customer this morning, and the reason you would move the nodes for them to the left is much more about understanding the critical path of the process and understanding what each of those critical stages look like to be able to predict the next stage. So the simpler the nodes, obviously the different view you're going to get of your process. Obviously, if you move the nodes right the way to the top, you want to look at absolutely everything to do with every task in the process. This is where you start to come more into analysis maybe of process efficiencies or reloops, or those strange paths that only happen maybe once ever. And they can be indicators, potentially, they might be indicators of fraud, or they might be scenarios that you've never built some business rules for, or they might be simply the outliers because of a certain scenario. So I guess it just depends on the intent of why you're analysing this process. And obviously same with the arcs. Wanting to see more and more and more arcs is probably, you may have a use case around trying to see, what are the odd paths that we've never catered for? Do we have been missing business rules, as opposed to having your arcs as far to the left as possible, where you're really trying to look at what's the most obvious and the most frequent way in which this process is executed. So it just comes back to intent, but it's a very, very good function. This is the sort of analysis that BAs in a traditional sense would probably spend weeks and sometimes up to months trying to get down to a level of detail where they can actually ascertain where are these reloop points and where are the outlier cases. Most traditional process mapping seems to result in missed understanding of those paths, especially when you've got an arc that might be only showing 5 cases out of 34,000 odd. But those 5 can hold the key to maybe some critical understanding of opportunities missed, or issues that might be underlying.
Yes, so basically it has to be use driven, and one way of starting could be to look at the most frequent nodes and arcs. So basically look at the typical case or the sunny day scenario, right? And this is what it could look like as a BPMN model in the context of this particular example. And then another thing that you can do is actually to swap the order, so invert the ordering. So instead of looking at the most frequent nodes and arcs, you could look at the least frequent ones. So basically all of a sudden your model captures the outliers, so the cases that are done least frequently. So that is another approach. So first you could address the sunny day scenario, identify as many issues as possible based on your strategic objectives, whether that is quality, compliance, efficiency, or a combination thereof. And then you could look at the least frequent ones following the Pareto rule of thumb of the 80-20, right? So you first want to address the top 20% cases that make up for the top 80% of issues, right? And then time and resources allowing, you can also look at the outliers. So to sum up, these abstraction settings are a way to quickly address your analysis to the cases that are of most interest, so that you can basically gain as many benefits as possible as quickly as possible, right? So, and there are different metrics that you can use to play along these abstractions. Another interesting, to close off on the topic of performance, another interesting overlay is that of duration. So when you switch to duration, basically the color scale changes because now you are looking at a particular duration statistic. You know, in the log we had the timestamp, right? For example, the timestamp of completion in this particular example. So the tool can use that as a starting point to automatically overlay average durations for the activities and the arcs. Now, in particular, if the log only has the end timestamp for each activity, like in this case, then the tool is clearly not capable of distinguishing the processing time of activities versus the waiting time in between activities. So it only annotates the arcs between activities with their average duration. And instead of the average, you can look at the total, the median, the maximum. So there are different metrics that you can use depending on what you're after. So as you can see here, on average, between the creation of the sales document and the change of the outbound delivery, there is a very, very long time of 1.19 years. Clearly, this duration also incorporates the duration of the previous task, because as I was saying before, in these cases where you only have the end timestamp, we are unable to distinguish processing time from waiting time. But if I pick another log, which does have both start and end timestamp, this is an example of a procure-to-pay log, when I switch to the duration overlay, then you can see that the tool is able to distinguish the processing time, like this is the average duration of each task, versus the waiting time. How long does it take between the completion of a task and the beginning of the subsequent one? So here we can also use a color coding to encode the duration of the task. The darker the color, the longer the average duration of that task. Similarly, we can engross, thicken the arc when that specific waiting time is longer than the average. And then this can be used to identify potential bottlenecks. So another type of efficiency, which is waiting, of waste, sorry, or inefficiency, which is waiting. We might find out that some tasks are longer than average, but in this case, this is a false positive. It's just the delivery of goods or services is meant to take some time. Actually, 1 day is not bad at all. But also we can find some nastier patterns that capture situations of bottleneck. Take a look at this particular activity. Analyze requests for quotation. The activity per se doesn't take long. It's about 23 minutes, which is on average on the same order of magnitude of the duration of the other activities, which are mostly also in the order of minutes. But the problem is with the waiting times to get into this activity. You see that all the incoming arcs into this activity have a very thick arc, and their duration is in the order of days, if not weeks, as opposed to the duration of the other arcs, which is in the order of hours, if not minutes. Now, this is a problem of resource capacity. I don't have enough people to analyze the request for quotation. So what happens is that purchase requests start queuing up at the doorstep of this task, waiting for a resource to become available to process them, right? So this is a resource capacity bottleneck.
But
And
it's also potentially an indicator of a opportunity for automation. You know, so if you think about the business rules required to complete that analyze request for quotation, if it's possible to systemize those business rules, you potentially take away that waiting time by having, you know, so that the business rules drive the automated answer to those. Now, this depending on what goes into that task, but it may be resourcing, it may be an opportunity for automation or business rule enhancement.
thank you, Ian. All right, so we have covered the transparency. We have also covered the efficiency by showing enhanced process models. There is also an opportunity to create performance dashboards where we can profile different statistics or create different charts to take a look at the performance of our process on an aggregate level, like distribution of activities, distribution of resources, resource utilization, and so on and so forth. We will actually show that in the context of variance analysis, which is the next, which is a technique that we can use for the next use case, which is quality. Now let's go back to our order to cash process. And we can see here that basically we have, as we said at the beginning, quite a lot of variance around this average. So we have 5.35 months as the average duration, with a minimum of a handful of minutes and a maximum of 3 years. So another powerful technique that we can use in the context of process mining is that of filtering. So there are essentially different mechanisms that we can use to slice and dice our log sets in order to focus on a specific subset of cases. It could be a logical driver, like the type of product, the geographical location, the type of customer, or like in the example that we are going to show, it can be a performance driver. For example, we want to segregate the fast cases, those that are performed within the SLA, say that orders should be dispatched within 1 day, versus the pathological cases, those that really take very long. So let's go to the filter interface. And very quickly, before going that, if you remember, in the context of waste analysis, we identified that there was a specific task, change scheduling agreement, that was repeated at most 35 times within a given case. Now we can use the same mechanism of filtering to actually isolate those cases where this activity is done a very large number of times. Say, for example, that at most we should allow the change of the scheduling agreement to be done 20 times. So let me look at all cases that actually take more than 20, where this particular activity is done more than 20 times. So there are actually 465 cases, which might be a significant number, where this activity is done more than 20 times. And then when I apply the filter, then I will be focusing only on those selected 465 cases. I will be seeing the resulting model as a process map or BPMN, but then I can also inspect the detailed case view and go one by one through the timeline of the various cases. So I can find out what activities were performed, by whom, in what order, and how long did each activity take. And then I have the case ID, which is basically the starting point for some in-depth analysis, because I want to find out why, in this particular case, like 113108, it took, we had to perform this particular activity more than 20 times, right? So filtering can be used to segregate, to isolate anomalies. But let's go back.
Whilst you're in there, whilst you're
Yes.
in there, do you want to just pull up the social interaction on that view that you just had 2 seconds ago and just show the resource?
Sure. So in Apromore, it is possible to dynamically switch perspective. Any categorical value that any categorical attribute in our dataset can be used as a starting point to switch the perspective. So basically the meaning of the boxes, of the nodes in the graph will change. If you remember, in our example dataset, we had the username, and there was a unique ID to identify the person who performed that particular activity within that case. So I can switch perspective, and you see that all the categorical values are there. I can pick username, and then I can look at all the different users and how they interact with each other when performing this process. So effectively, what I'm discovering is the social network of interactions between the process participants. And the same overlay and abstraction, as well as filtering capabilities that exist on top of an activity-centric process map, they also exist on top of a social network. For example, I could switch that into a BPMN model. Or I could change the overlay. Instead of looking at the cases, I could look at the maximum, right? Maximum number of times a given user has been observed within a case. Like there is this user 88 that has been engaged 35 times in at least one case in my log. And I can also look at the handovers, because the arcs in this case represent the handover between activities and what handovers are most frequent. Like it seems that there is a ping pong effect between user 298 and user 42. So that is something we may want to put our attention upon. For example, we might want to isolate this particular filter, and there are some keyword combinations that we can use. For example, control right click to focus on all the cases, those 444, that actually transition through that particular arc. So these are the 448 cases where I have observed a ping pong effect between these two particular users. And then once again, I can actually look at the timeline of those particular cases.
And whilst in that example, we're looking at specific users, your data might end up having team names, or you might be using that social interaction view to look at the different interaction in different geographical locations. So the same process repeated in let's say five different geographical locations, or 5 different offices or different states, to see what the relationships between the users are in different contexts, and to try and understand, whether there are specific scenario or geographic differences, or whether it's simply a variant that is undesired.
Yes. So now what I've done, coming back to the quality dimension, so using a technique called variant analysis, I've cleared my filter and I want to create a new filter. As I was saying before, Apromore offered a wide range of filtering mechanism. You can filter by case variant. That is the path, right? The path that each order can follow. So you can look at the specific order of activities. Here you see a specific path, and then you can focus only on that path. And you can also focus, for example, on the most frequent such paths, right? So that is one type of filter. The other is the case ID. We have found out that this particular ID it relates to a case where a given activity has been performed too many times. So I may actually want to filter on that particular case, or actually look at who did what, right? Or by specific attribute. And here you have the full set of attributes that you have in the sublogs, like for example, the fiscal year, the order quantity, the username, the time frame, like you may want to look at a specific time frame in the log, and so on and so forth. Like in this case, let's focus on the performance filter. You have different performance measures that you can choose. Let me focus first on the so-called positive deviances, like those cases that take up to 1 day to deliver the order. Of course, I don't know. This is a real-life log extracted from a company and anonymized, company that is running SAP. But of course, I don't know their SLAs. So let's assume that an order is fulfilled within the SLA if that is completed within 1 day. So you see that that leads to 4,900 cases. So I apply that and I seal the filter model and log. So what I can do now is that I can export that. Let me export this filtered log because I can use it for subsequent analysis. And let me export it to the resulting BPMN model that I can get out of that. That would be basically this model here, right? And when I say export, it means to saving it back into my repository. Like this is the log, and this is the model. And I can do the same for the pathological cases, the very, very slow ones. For example, those that take more than 2 years to be completed. You see that there is a long tail here. If we put this in logarithmic scale, we can see it better. So let me focus on those that take 2 years. And I want to specifically exclude, say, the norm, anything that is in between 1 day and 2 years, right? So I apply that, and that leads to 2.3 thousand cases. And then again here, I can export the slow cases as a filtered log, as well as a filtered process model in BPMN. So now that I have materialized these artifacts back in my portal, I can play around with them. Specifically, I want to contrast them, and I can do them on the basis of the process map, or I could do them on the basis of a performance dashboard. So let me select the 2 filtered logs, referring to these 2 variants, fast and slow cases, and let me trigger another plugin, the performance dashboard. This will basically allow me to compare on a statistical level different variants. In this case, I'm comparing these 2 variants. Something interesting here is the distribution of active cases over time. The blue are the slow, the fast are the red. You see that there is more or less a uniform distribution for the slow cases throughout my time frame, whereas the fast ones, those that get completed within 1 day, actually happen in a very, very specific period of the year, in between the months of July and January, basically 2017. So basically in the last half of 2017. And now what I can do to try and find out why these cases take much longer than the others is to, for example, build a custom dashboard where I can analyze different performance dimensions. So first of all, I can build some basic stats about the log. So for example, I want to see the number of slow cases versus the number of fast cases, right? So I'm looking at 2.3 thousand slow cases versus 4.8 thousand fast cases. And here I can look at their, say, average duration, right? So the average duration for the slow cases, that's 2.36 years. And then the average duration for the fast cases. And that should be sensibly lower, 7.68 hours. So this is just a very high level summary, just to make sure that we're looking at the right data sets. Now let me add a chart where, for example, I compare the a given attribute, which could be the order quantity, right? I want to see if there is a difference in the order quantity between the fast cases that are again in red versus the slow cases that are in blue. And here I can put them in relative terms because you see that the number of cases is different. I have basically less than half of slow cases compared to the fast cases, but you see that basically the distribution is pretty much the same. So let me now take a look at the distribution of activities to see whether there is a significant difference in the type of activities that are performed. Let me look at the total frequency, put again in relative terms, and now I can see some interesting patterns. For example, I can see that change scheduling agreement occurs significantly more in the slow cases than in the fast cases, whereas a change out, and so this could be the reason. Remember that activity change scheduling agreement that we found that was performed very frequently. See, this occurs in 66% of the times in the slow cases as opposed to the fast cases, where it basically never occurs. Another differences would be the create delivery document is more frequent in the fast cases, as well as the change outbound delivery. So that activity might actually be another reason why the fast cases are faster. So basically, along the way, they are changing the outbound delivery to identify faster routes, right? So basically, you can use this dashboarding to identify differences on a statistical level between the variants to try and understand where the root causes for such differences are. And of course, you are not bounded, answering a question that we have here, you are not bounded to Apromore SBI. You can export in CSV format all the stats that are generated by the tool and import them into the business intelligence tool of your choice, as well as you can use an Apromore connector to integrate it with a set of BI tools like Tableau, ClickSense, or Power BI, or Cloud Air Analytics, right? So you can use the standard CSV export or the connector to directly link it to these other BI tools. Right, so that was variant analysis. Maybe we very quickly cover compliance and wrap up, given the time. Another interesting use case for process mining is that of compliance. So basically, the idea of compliance is to check whether certain business rules are complied with in your process model, the one that you extract from the log. Or you could check whether you are conformant to a BPMN model that is normative and that you have created by hand, or that is coming from your vendor or some industry standard like AQPC, process quality framework. So for example, coming back to this example of procure to pay, we might have a 4I principle between the release of the supplier invoice and the authorization of for payment that need to be done by two different financial officers. So what I can do is that I can set a so-called path filter where I want to check that between the release of the supplier invoice and the authorization for the payment, the resource that performs these two activities is actually the same. So basically, I want to see whether that particular 4I principle is violated or not. And then I actually want to take the fragment of the process where those two activities are involved, because I don't want to look at any other activity, just authorize supplier invoice and release supplier invoice for payment. So what I do is that I apply this to filter, and indeed I see that there are 242 cases where these two activities are performed by the same resource. So now I can switch to the resource perspective, increase the slider, and I can actually see what are the resources that violate this 4I principle. And in this particular example, I have two people, Caralda and Pedro, whom we might want to have a conversation with because they tend to very frequently violate this 4I principle. So that was super quick wrap up of another use case, which is compliance. And very, very quickly, finally, for agility, basically the idea is that you can build some performance dashboards, some predictive performance dashboards, like the one that you see in the screen, where basically we are predictively monitoring the performance of different suppliers that we use in the context of some order-to-cash process. So, for example, we can predict on a case-to-case, case-by-case basis how long it's going to take to complete that particular case, so the remaining time. We went into timeouts, so how long it's going to take to complete that case. Then we can predict, for example, the outcome. In this case, the outcome is, for example, whether the supplier is going to deliver on time or not. And
no, I was just going to say some of the interesting use cases for these predictive dashboards. You know, where you have a process which obviously has multiple steps, and let's say step number 7 relies on understanding, when step number 3 might necessarily be completed. So trying to get earlier initiation of activity to try and short circuit some long running processes. this can be set up and configured to tell you that if your critical event might be event number 3, and that's the trigger for event number 7 to commence, you can start to set up some dashboards that might tell you that, okay, the next orders that are in line to be shipped, for the sake of argument, are, you know, order number 1, order number 3, order number 7, order number 10, and that's based upon knowing that that activity for the loadout or the shipping needs to start when event number 3 finishes. And so being able to predict when event number 3 is going to finish then will help you to arrange resources downstream.
Yes, and as I was saying, there is a range of predictions that you can issue. For example, a value like a remaining time, an outcome like whether, for example, the supplier is going to deliver on time, what is the next activity, and what is the predicted case end. And this can support an operation manager to, for example, allocate resources in order to avoid cases from completing late, so violating the SLA. All right, so I think that as a demo, that is it. We covered different use cases, transparency through the automated discovery of a process model, efficiency through the enhancement of the model that we discover from the log by means of different statistic overlays related to frequency and duration. We also looked at the performance dashboards. Specifically, we looked at that in the context of variant analysis, a technique that we can use for quality as a driver for process mining. So we used filtering in comparison with, filtering in combination with comparative dashboarding. For example, we segregated fast versus slow cases, and then we looked at different performance charts in order to identify key differences that could determine the reason why, could be the cause why certain cases take very long to complete. Then we quickly looked at the last 2 use cases, compliance, by checking the compliance of a 4i principle to a 4i principle, and then in agility we just quickly looked at a predictive monitoring dashboard. Right, so there is one more question that we haven't answered, and then of course, mindful of the time, we can perhaps spend 5 more minutes to answer some remaining questions if there are. So there is one about how is Apromore integrated with other business data systems? Is this manual import-export? So there are a few formats that we can use to import logs. We can use a CSV format like the one in the example that I showed before, or a more compressed format that is called Apache Parquet. We can also, that is supported, for example, by tools like Cloudera. We can also use some XML formats like XCS or MXML. We can import also from URLs like, you know, a Dropbox folder or a remote folder where some system is pushing some data to be refreshed at a given temporal cadence. Or we can use an integrator like a connector to automatically fetch this data from a given source system. For example, this SAP example has been obtained by using our SAP connector that supports all the sales, procurement, accounting, fixed asset management, and supply chain management processes that come out of the box from SAP. And there are other connectors available like Salesforce or ServiceNow. And the same goes with the analytics that are created by the dashboards, whether there is a predictive monitoring dashboard like this one, or has an historical dashboard like this one. All these analytics can be exported in CSV or Parquet so that you can import them into the BI tool of your choice, or a connector can be developed, like for Power BI, Click, or Tableau, though all these tools already import CSV.
Another interesting question there, how do you align the process maps generated by this tool to the existing hierarchy of the organization? Should we do mining to discover the process models instead of traditional process modeling, or should we do traditional modeling first and then mining for conformance? I think, once again, depending on your use case, I would suggest that the automated discovery through a tool like this not only short circuits the BA time required to get the process understood, but obviously gives you a massive amount of data to start analysing. So if the intent is for your business analyst to spend a lot more time analysing than modelling, you would certainly start by process mining. The use case for, I think, traditional process mining is if you, traditional process modelling is if you have a benchmark model or a model to which you are confined in terms of your conformance, then obviously you would bring that as your baseline, but then do the process mining second. But depending on whether your business needs to understand the reality or whether they want to start with an indicative view and validate that, I think there's no right or wrong answer to which way you start. I think the biggest determiner as to why you would potentially start with process mining is to really get your timings, your frequencies, your variance, and your process discovery done in a fraction of the time that you would spend doing traditional process mapping. I mean, for anybody that's done a time and motion study, across multiple business units, that's months of work to get the type of detail that this will provide you in minutes. And I think, from that end, at least you're starting from a base of straight into analysis as opposed to spending a lot of time interviewing.
Well, there seems to be no more questions. So other than that, I think we'll just say thanks all for sticking in. I hope that's been a really useful session for you in terms of getting to know what process mining practically looks like using a tool like Apromore. So again, thanks Marcello, and thanks Ian for giving up your time to walk us through that. We'll be sending out this recording and a copy of the slides in an email. You'll get it overnight and you can watch it if there's certainly some things you wanted to rediscover. We'll also send a link if there's any questions you've got, if you want to contact Marcello or Ian about something specifically that might apply to you. Otherwise, thanks again for joining us, and we'll see you next time. Thanks, Ian. Thanks, Marcello.
Thank you very much.
Pleasure.